Hello and welcome again to Redspan Creations, where we all learn, create, and improve. Now in this video, we will be learning again another topic, and that is about dimensions, units, and measurements with SI or metric system examples. Now if you're ready, please keep on watching and perhaps you can get a pen, paper, or whatever have you, so that you can take down some notes when you watch this video. Now let's get started. Now what are dimensions? Dimensions are quantifiable or measurable features or extent of maybe an object or an entity. They can be measured using measuring instruments or devices and made sense with numerical values accompanied by relevant units. Now, this sounds a mouthful, but this is just a simple, a simple idea or a simple concept. So, let's try to make sense of that using this example here. So, when we say dimensions, these are what you hear usually the 1D, 2D, or 3D. So, where did they come from? Imagine, for example, a Cartesian plane. Pardon my dog who is snoring that you might be hearing now. So, for example, you have a Cartesian plane, which is very much crooked. Please don't mind the drawing. Okay. So for example, we have here a point in the reference area or reference. This is the reference point 0, in the Cartesian plane. So that point 0 is in fact a 0-degree dimension because it's just a point. It can be anywhere in space or anywhere in this Cartesian plane. So let's have another example. Let's say 1, 2, 3 from the x-axis and 1, 2, 3, 4 up to the y-axis. So we have another point here that is 3, 4. So that's another 0-degree dimension. Now, let's connect these points and you will see a line. Line is an example of a 1-degree dimension. This is what you usually hear 1D. This is not the 1-dimension band, but a dimension that is in 1 degree. Why is it in 1 degree? Because it has a unit or a quantity that we can give a value in 1 dimension. So let's make that make another one here. So from the reference point to another point here, so 1, 2, 3, 4, 5 points from the reference point, so that's 0. So that's 5, 0. We can actually make a line there, and that line there is another 1D example. So here we have a length. Actually, that's a length. That's a unit or a dimension that we can quantify as 5 units. So that's how you visualize how 1D works. Another example may be this one, another clearer example. So let's say here we are making this one, a line that we did earlier. So we have here 5 units. So that's your 1 degree dimension, or 1D. Now, that can also be done in the y-axis, of course. So we can also have it here. So this one here, 3 units up. So that is your dimension there. Now, let's make a 2D example. So if you have 5 units here, and then let's just delete this one first, and then make the 3 units go up here. Let's just put it there. 3 units here. Oops. Three units here, and then extend it to its parallel. Extend it in a parallel manner. So you have another 5 units here and another 3 units here. So you now have 2 degree dimension. Let's change the color. Let's make that yellow. Let's make that yeah. Let's do it one more time. Okay. So 1, 2, 3, 4, 5 here. You have 5 units here. And then 1, 2, 3 up. And then make parallel lines. There. So now in this case, as we said before, there is already a 2 degree dimension present here. So if that is 2 dimensions, we have what we call the length and the width, right? Those are the length and the width dimensions. Now, previously we only have here length. So that's your 1 degree dimension. Oh, oops. 1 degree dimension if an entity has only 1 degree dimension. But if it has already the length and the width, that's already in 2D. Now, let's extend the Cartesian plane with a z-axis. Now, in the z-axis, that's a different story. So that's not anymore a 2D. Now we are now making 3D. So if you have a measurement, for example, 1, 2, 3, 4 units along the z-axis, and extend that there, extend it there, and then make parallel lines for the width and the length. Now you have what we call a 3-degree dimension. So that is closer to real life, or that has the x, y, and the z parts of that dimension. So, oops. Let me just put this 2-dimension up, just a notation so that you won't forget. 2-degree dimension. Okay. Now the violet ones, I'll just put another line here for the violet. So you have here 4 units along the z, 3 units along the y, and 5 units along the x. That composes your 3-degree dimension. So this is what we call a rectangular prism. Now the shape that we previously did, this one in yellow mustard color, this is, you're correct, a rectangle. Now this one is what we call, this one in 1D is what we call a line, of course. Line, or maybe line segment. Okay, I hope you're trying to follow our discussion here. Now let's have more examples. So let's have, let me just, okay, let's have a section here. What if we have this, what if we have a square? Example, that's a square. All right. So that's in 2D, right? That's in 2D. But if we make that in 3D, let me just make it consistent to the color. Okay, that's a square. Now, what do we do if we make that, or what do we get if we make that a 3D figure? So if we will be making that into 3D, we extend it to the z-axis, and then we will be getting a cube, right? Another example, what if we have a circle? And then we want to make it 3D. We imagine it, or we make figures around it, around the z-axis. So making that, that will be made into a sphere. All right, so that's how we understand, or that's how we make sense what dimensions are. So if you have questions, maybe you can type those in the comment section, or maybe you can book a schedule with me to have a tutoring or coaching session. But I hope this is enough for you to understand dimensions better. Now, if you do understand, and if you already have no questions, let's move on to the next one, which is units. Units are standards of measure chosen or decided upon to represent the values of the measured dimensions. Now, let's put an emphasis to the word, let me just get my color red. Oh, never mind. Here. Chosen or decided upon. Why? There should be an agreement in the scientific community so that all things measured are precise and accurate. So it's not anymore like the old times when we refer to a distance, oh, it's from here to there, from my line of sight to that mountain. But now we say it's 5 miles from here. It's 500 kilometers above sea level. Something like that. See? So we should have units that are standards or agreed upon by the scientific community. So examples of which are SI system and English system. For this video, we will be having examples in the SI system, or what we call metric system, what we also call as metric system. And units can either be classified as fundamental or base units or derived. Another focus in this video is that we will be discussing fundamental or base units. There will be a separate video for the derived ones. Now let's move on and have this table. Let's fill the table with some details here. We said that there is a system of units. There is an agreed upon system. So we will refer to the SI metric system. So there are 7 of them. There are length, mass, or these are length, mass, time, temperature, amount of substance, this is more of the chemistry or physics related measurement or unit, and we have electric current, and lastly luminous intensity. All right, so these are our fundamental or base quantities. So for length in the SI system, we use the unit meter, abbreviated by the letter M in small case. Now for the mass is kilogram, measured in kilograms or kg. And then for the time, we have second, which is of course letter S, small letter. And then we have temperature, which is measured in Kelvin with a big letter K as its abbreviation, or as its symbol rather. For the amount of substance, we have a concept which we will be studying in the future as mole. And we usually abbreviate it as mole without an E. For the electric current, we have ampere, which is symbolized by the capital letter A. And lastly, we have candela for the luminous intensity or the intensity of light. Candela is represented by CD in small letters. So these are your fundamental quantities, and you will be seeing more of these in the future videos. And some other systems of units will be introduced to you rather. For example, the English units, the CGS, and so on. But for now, we will just focus with SI or metric system. So I hope you can memorize these ones because these are very important. And oh, by the way, Kelvin, most measuring devices don't usually measure Kelvin as it is. Kelvin is computed when degrees Celsius is measured. For example, we measure the room temperature as 25 degrees Celsius, or the room temperature is measured by the thermometer to be 25 degrees Celsius. In order for it to become Kelvin, we just add 273.15 to the measured value. So that will be 298.15 Kelvin. Oh, this is temperature. Okay, so don't forget that this will be an important step, especially when we discuss physics and chemistry topics. Alright, so if this is clear, we move on to the next. But if you have questions, you can put them in the comment section, or maybe you can book a tutoring session with me, as I previously mentioned. Now we have here lastly measurements. Measurements are numerical are numerical quantification or expression of values reflected on measuring instruments or devices, meaning these are the numbers found on your measuring devices. Okay, so most of the measuring devices in the countries that use SI system have SI system devices, or are read using SI system or metric system. But I think in US they're using the English system. And for example, in Canada, I think they're using metric system. Most parts of Asia are also using metric system. I'm not pretty sure which countries also use English system, but maybe some EU countries. Okay, that's just fun fact. Alright, so here we have some common measuring instruments. Now let's start with this one here. This is what we call a tape measure. And this is a part of your measuring tape, metal measuring tape. the handymans or the carpenters or contractors or architects, engineers usually use this. This one here are used mostly by tailors to measure the body parts so that your clothes will be perfect fit. Now, let's try to zoom in here in this part of the measuring tape. We have measurements in feet and in meters. And this one here, the front part here is measured in inches. And this one is measured in millimeters, I think. Or in cm. Yeah, millimeters. So there are measuring devices that may give you SI or metric systems. So as we said earlier, we will be focusing on SI. So here, this part here at the bottom has a 5 feet long tape. So it means to say that each unit here is measured in centimeters. So this is 1 centimeter, 2, 3, 4, 5 centimeters. Okay, let's use these or use this in an example. So what if we have an object that is measured or an object that has a length measured here like this, like so. So our measurement here, if this is in centimeters, that will be 1, 2, 3, 4, 5, 6, and making it as accurate as possible, that is 6.6 centimeters. So that's how you use it. And that's actually the numerical value. The numerical value here is actually your number. The measurement is both the number and the unit. Okay, so let's have another one. Oh, by the way, these instruments or these objects measure length, obviously, or maybe width and height. Okay, now these things here in the middle, just like the tape measure and the measuring tape, the metal measuring tape, they also have different measuring, what do we call this? Measuring units. So we have here, this one I think is in pounds. This one is in kilograms. So since we are using the examples for SI, we will use this one above, and then this one here is the same. This is in pounds or in lb, and this at the bottom is kilograms. Now let's see what the measurements are. So for this one, what do you think is the measurement here? The measurement is between 30 and 32. But to make it more accurate, to make a more accurate measurement, we have here the one in the middle. That's 31, right? And then we have 1, 2, 3, 4 lines before 32. So how do we read that? Let's just make an approximation. That can be 31.25 kilograms. So that's an example of the measurement for this one. Now here we have a measurement between 60 and 70, but we have here 65 in the middle. And then we have lines 1, 2, 3, 4 lines before 70. So that will be 69 kilograms, right? Okay. This is just easy, right? So these devices here, measuring devices here, are concerned with the mass, or sometimes weight. But we will have a separate video to discuss the difference, the exact and technical difference of mass and weight. So let us just leave that as it is. Now, going to the next one, we have these. Of course, you know this already. These are objects that measure time. They measure time, right? So what could be the time here in this watch? The time in this watch is, it's easy, of course, to know, because I think everyone knows how to read watches, the analog ones, not the digital ones. So if not, let's see. So this represents time that is between 10 and 11, right? So that is 10, what could be 10 for the shorthand. Then now looking at the shorthand points at between 10 and 11, so we can just use 10. And then the longhand points here just after 30 minutes. So that can be, let's estimate that to 31 with a millisecond. This is 0.5, right? 31.5 with seconds. That is, oh, anyway, let's not mind the milliseconds. Let's just say that is 10:31. So what do we mean by 10:31? We measured that there is a 10-hour measurement and 31 minutes according to this watch. Now, if we refer to this stopwatch, this is at the reference point. It still hasn't moved. It still hasn't been used. So that points at perhaps 0, 0, or if that has case 1, case 1 not started, or case 2 started, we have a measurement of time which is 60 seconds. So 0 hours, 0 hour and 60 second, or 0 hour and 1 minute. Okay? So I hope this is clear, and we move on to the next and the last one. So here we have another set of objects. We have here a multimeter. Does anyone know what a multimeter is? If you know, please comment down below. A multimeter measures volts, current, or perhaps even the resistance in electrical devices. So here, if we zoom it here, we have a measurement here that is in A. Familiar? Or do you remember this? 10A means 10 amperes. Right? So this multimeter can measure current, specifically electric current. So in this case, the multimeter reads 0 amperes. Right? Now, to see what's the measurements are here, we have these instruments. Of course, we are familiar with this because this, especially this one, this is a clinical thermometer. Thermometer. Oops. And then this one is a room thermometer. So, usually for a room thermometer, it has Fahrenheit and degrees Celsius. But for the clinical thermometer, we have degrees Celsius. And as we said earlier, the SI unit for temperature is in Kelvin. And if you recall, we convert the temperature in Kelvin using the measurement in degrees Celsius. And then we add 273.15 to get the value. So here, let's have the clinical thermometer. This one is, let's just zoom that, more than 38, but it's before 39. So that's also before 38.5. So that is around 38.4. 38.4 degrees Celsius. So getting the temperature in Kelvin, 273.15 plus 38.4 degrees Celsius, we have, let me just get my calculator. You can get your calculators too if you want. 273.15 plus 38.4 gives us 311.55 Kelvin. That is our temperature. And then for the room temperature, let's see. So in the degree scale, we have below 0 degrees. Oh, By the way, if we have a reference temperature in this scale at base 0, everything above is positive, read to be as positive temperature. But if the value goes below 0 degrees, that will be negative. So in this case, it's a negative value or a negative measurement. So here we have 10. So one line here represents 2 degrees, negative 2 degrees. But this the mercury, the supposed mercury, the scale, the measurement here is between the first line after 0 degrees, first line below it. So that will give us the temperature to be -1 degrees Celsius. So computing the temperature in Kelvin, that's 273.15 plus -1 degrees Celsius, that will give us a temperature equal to 272.15 Kelvin. Okay? That's easy, right? So again, these devices measure temperature. Oh, lastly, we have these ones. This is what we call photometers. The value here that will be reflected, oh, by the way, the value that will be reflected here will be measured in candela, right? So this is a ball, actually. This is a round ball, like the ones that you can see in the mouse previously, or the mouse before. It's like, if you can imagine, that's like a roll-on deodorant. Just to imagine. Or a ping pong ball. Table tennis ball. Or ping pong ball. It's like that. So if a light, a speck of light, or any light, or an open bulb, or anything with light is exposed to this part of the photometer, the amount of luminous intensity will be reflected here in this meter, in the photometer. So this one is a more portable one, a more compact one. So that's another variation of the photometer. So usually, the people who use this are, of course, scientists, or photographers. Why? Because the quality of the pictures or the quality of the videos are dependent on the light, the drama, the quality, the aesthetics. That's actually the basis of photography. So maybe the photographers or videographers. Graphers.